Hey guys, we're going to talk about projectile motion. What are projectiles? How do we deal with these things? How do we solve problems? Okay, good news and bad news. Good news, no new equations, no new mathematics, no new problem-solving strategies. It's all the same stuff that we've been doing. You're still going to relax, read, draw, make a chart, choose one of your three kinematic equations to use to solve the problem. All that's the same. Now, bad news is that these problems are more complex because instead of something going left and right or up and down, you have something going left and right and up and down at the same time. So what does that look like? Let's get into this, right? A projectile is any object that's been launched in some way and it's moving through some space in both the x and y axes. These are, this can be something as simple as a ball being thrown or kicked. Right, something dropped out of a plane. So here's one definition of a projectile. There's a lot of them out there. This next one I like even more. Now, there are all these options as far as what a projectile can be, and really it can be anything. Right, vomit can be a projectile. So there's a trick to doing these problems. We're going to talk about how this works. Projectiles are special because they move in two directions, right? So if you have a ball that's been kicked, let's say it's a football and it's being punted, well, the football would move in the x direction across the ground, and the football would also move up and then back down. An old question that every physics teacher has asked. So imagine I have a rifle. It's a very special rifle. So what happens is when I fire this thing, one bullet comes straight out of the barrel and goes that way. Another bullet is dropped. There's like a little trap door right next to the trigger, and a second bullet is essentially just dropped straight down at my feet. I have to hold this thing perfectly parallel to the ground. So the question is, which bullet hits the ground first? Is the one that goes, right, or the one that's just dropped? And if you watch some of the videos I had for you in the module, you should know roughly what's going on here, right? In the real world, the bullet that's dropped is actually going to hit the ground first, and then the one that's fired is going to arrive shortly thereafter. That's really not what's supposed to happen. Both bullets are supposed to hit the ground at the same time. This will happen if you take away air and any friction. Now remember, all of our problems are in physics land, so there's no air, there's no friction. We get to turn that stuff off. So it's kind of like if you're launching something or throwing something out in space. If you throw something out in space, it just keeps going forever until it's acted on by some outside force. And we humans, we have done this. We've actually launched things out in space, and they just keep going. So if we turn air off, we turn friction off, then what happens? We have these two bullets. One bullet goes this way real fast, and one bullet is just dropped. Yes. Now, what's the same for both of these bullets? As soon as they leave this rifle, this one's going this way, and the other one's being dropped. The moment they leave it, what's the only thing acting on both bullets? It's the force due to gravity. Both bullets are going to start at the same height because they're in the same gun that is parallel to the ground, and then they're both going to go down. Okay? Because they're both acted on by gravity. Now, some people think that because this bullet is being fired out the front of the gun, it's going really fast this way, and going fast this way has something to do with how it moves this way. And what I'm here to tell you is that this is a big deal in all of physics, and this is a fact that you need to write down. Fact. Motion left and right, motion in the x, and motion up and down in the y-axis have nothing to do with each other. They are independent. That's a fact. So how something moves, how you move left and right, is independent of how you move up and down. Okay. So both bullets should hit the ground at the same time. It's just they're not going to hit the ground at the same place because one's been fired out like that. Okay. Now, knowing this, how do we work problems? Well, these are hard because this is not what we see. When something moves left and right and up and down at the same time, it has this parabolicness to it. It has this curviness, and so people say, oh, it's moving in like a big arc. What's really going on is it's moving left and right, and it's moving up and down. And so we have to take these two things and we have to separate them into their up and downness and left and rightness, and we have to deal with those two things separately. And that's why these are hard problems. Okay? In order to do that, we have to take air out. So I'm going to show you how this works. I like to do I call them cliff problems because they involve cliffs. What's a cliff? That was from one of my favorite films, right? The Princess Bride, and they see the cliffs of insanity. So a cliff is pretty much anything that is, at some height above some origin, right? This is a cliff that I drew. What can be a cliff? Well, a cliff. A tabletop, something rolls off. A plane flying like this, and it drops some package. That can be a cliff. So these are what I call cliff problems. Okay, so I want to try. Okay, a stone is thrown horizontally at 15 meters per second from the top of a cliff, and then they're going to ask us to solve for some things. Okay, so a problem may look something like this. It's a word problem. Okay, so how do we deal with word problems? Step one, relax. Relax. I'm in a nice quiet place. I have my coffee. Relax. Step two, read. I read the problem, maybe more than once. Maybe I underline things. Step three, draw. Relax, redraw. The stone is thrown horizontally from the top of a cliff. Okay, so I have a cliff. Boom. Stone. Done. Now, physics is all about reading. Sometimes I'm bad about this. If you read this closely, it says the stone is thrown horizontally, which means it's going to come off of the cliff in the X. That's one thing that we can figure out. Now, how is this thing going to move? Well, as soon as it clears the cliff is when it's going to kind of do that business like this, and it's going to have an arc shape, right? And it's going to impact the ground somewhere down here, right? So that's what's going to happen. Now, initial velocity is 15 meters per second. So I'm going to put that in my picture. It's 44 meters above the ground. That's the height of the cliff. From the top of a cliff, 44 meters high. So that would be this displacement. That's a y thing. This velocity is an x thing. Okay, so relax, redraw. I drew some sort of picture. Okay, now I'm going to make a chart. In my chart, boom. Now, there's one other thing we have to do for these problems. So I told you guys that motion in the x and motion in the y are completely independent, right? So this velocity, I told you that's an x thing, whereas this height is a y thing. So where do I put these things in the chart? Well, here's what you got to do. I'm going to make a chart that has two columns. I have one column for all my stuff going left and right, and I have one column for all my stuff going up and down. So, you see how these are a little more complex, right? We're still making a chart. Now I'm going to go ahead and put in some values that I know. This is all my x stuff that I know thus far, right? I'm going to assume that this position, where this ball starts, we'll say that it starts right here at the tip of this cliff, and it's going to go out in the x. We'll call that 0. So this is my 0 position right here, okay? Now, this looks a little strange. I'm saying that the initial speed in the x is going to be 15 meters per second, and the final speed is the same. And my acceleration in the x is 0. Why? Why is that the case? These two speeds will always be the same, and your a in the x is going to be 0 because we're turning air off. We're turning friction off because we can do whatever we want because it's physics land. So I'm going to turn those things off. If you have no friction, then everything that's going this way, right, your x stuff, my x speed is all going to be constant because there's nothing slowing it down going this way. There's no friction. There's no air. It's like it's traveling out in space. It's just going the same speed all the time. So in your x column, you're going to have things that look like this. Okay? Values. Let me show you how I decided on these, right? They said that the cliff was 44 meters high. So I'm going to call this down here at the ground, I'm going to call that my 0 mark in the y. That'll be 0. Okay? Which means it is above that 0 mark. So I'm going to call this up here my positive 44 meters. Okay, that's 44 meters. All right. The way I usually do this is anything that's going up is going to be positive. Anything that's going down is going to be negative. That's the way that I always approach problems. Okay. So if the ball is above this, I'm going to call this my origin, right? If it's above that, then that's going to be a positive. So that's the initial. That's where it starts. It ends up on the ground. That'll be final. Okay. My initial velocity in the y is going to be 0. Why is that? Right? It's being fired this way horizontally. As soon as it clears the cliff, the force of gravity is pulling on it, and it's going to start accelerating downwards. Okay? And it initially doesn't start moving very fast, but, you know, gravity is pulling on it the whole time, and so what happens is that after a certain number of seconds, it's going to be going faster and faster. It's accelerating just in the negative, direction. It's moving downward. Okay. The fact that it's being fired outwards bothers folks, but remember, x and y are independent. Right here, the ball, as it's going to travel this way, is going to be 0 meters per second. Okay. And then finally, what's my acceleration in the y-axis? Well, it's going to be negative 9.8. Why? Because we're on Earth. Can you have two different accelerations? Yes, you can. You've got two different motions. Motion in the x, motion in the y. They are independent. Again, here's the problem. Part A, how long does it take the stone to reach the bottom of the cliff? How long does it take? What is that asking us for? What are we looking for? Right? Now here's the rub. You have two options. You have an x column and a y column. So you just have a lot of options. And basically what you do is you say, all right, I'm looking for time. I have to choose a column. And this comes down to experience. This is a bit of a trial and error type thing. You pick a column. Okay, you can't mix. You see how I've drawn them in different colors? They are not supposed to mix. So I have to choose a column. Okay, a column. And I will tell you a few things. One is you will be choosing that column more often than not. Not always, but the majority of the time we start in the y column. If you look at the two columns, I actually know more in the y. Yeah, I've got a couple of zeros, but I also have a few things that are non-zero. If you look at the x column, you see how I have two things that are the same, and then I have two zeros? What's going to happen is I'm going to pick some equation and start to plug these in. And I'm going to get a nonsense answer. And if that happens, that's okay. That just means you need to try a different column. So I'm going to choose the y column. Then you're going to choose one of your three equations. We're solving for time. I'm going to use the y column. I have my green marker, so I have to pick one of my equations. So which equation has all this stuff in it? Turns out equation number 2 is the one we use a lot in projectile motion. We don't use it exclusively, but we use it a lot. So here we go. It's hard for me to write my mouse, but that's it. So there's equation number 2. It's in green. That matches up with the y column. I'm now going to substitute numbers in. That means change in y. Final minus initial. So if it starts up here at positive 44 and ends up down there at 0, that's 0 minus 44. It becomes 0 because my initial velocity is 0. So 0 times anything is 0. Okay. Now I'm going to simplify. I got to solve for t. 4 on the left, and then I have half of negative 9.8 is negative 4.9 times t squared. I will divide and take the square root. I get about 3 seconds. So it takes about 3 seconds for the ball to fall, right? So it takes about 3 seconds for the ball to get from up here to down here. Now, I can put that in my chart right here. Now the question is, what time can I put in the chart right here? It takes it 3 seconds to get from here to there. It should follow that it should also take it 3 seconds to go from here to here. Doesn't the whole ball have to be right here? So if you find time in the y, you now know time in the x. From the base of the cliff, does the stone strike the ground? This displacement, which we call range, and that would be this in the chart. Choose an equation, try it.